We create classes only for the nouns and noun phrases that have significance in the ATM system. Though the requirements document frequently describes a transaction in a general sense, we do not model the broad notion of a financial transaction at this time. Transactions can be, for example, of any of our, let's say, withdrawal can be a transaction, a deposit can be a transaction, but since our requirements document describes it generally in a general sense, we have only included the specific cases of transactions, for example, the withdrawal or the deposit in our system so far. Instead, we model three types of transactions, that is the balance inquiry, withdrawal, and deposit as individual classes. These classes possess specific attributes needed for executing the transactions that they represent. Classes we can, for example, brainstorm some of our main classes that our system will require. One of them will be the ATM, the screen, the keypad, the cash dispenser, a deposit slot, account, bank database, balance inquiry, withdrawal, deposit. These can be our potential classes. If we count, we have identified at an initial stage that we will have 11 classes in our proposed simulation of the ATM machine. And as we can see, these classes will have their own attributes and their own operations. How do we identify or model the attributes or the operations of our classes? Now, one way would be to pick up your keyboard, pick up your laptop and start building the classes. Another way would be to have a design of your classes, the relationship of your classes. You have identified the variables that your classes are going to have, the operations that classes are going to perform. Model it in the form of a diagram, including the relationships or the potential relationships of those classes, and then go on to build your software. Now, a UML diagram enables us to model via class diagrams the classes in the ATM system and their interrelationships. Now, figure 12.6 is in this slide. You will not find this chapter in your book since this is from one of the older versions of the book, older editions of the book. But you will find most of the details in these slides. Each class is modeled as a rectangle with three compartments. We know that the class diagram of a UML class diagram of a class has three compartments. The top one contains the name of the class centered horizontally in boldface. The middle compartment contains the class's attributes. The bottom compartment contains the class's operations. For example, this is a class diagram for the ATM class. Now we have the name of the class at the top in the top compartment. Class diagrams also show the relationships between the classes of the system. For example, our next figure will show how our classes ATM and withdrawal relate to one another. Notice that the rectangles representing classes in this diagram are not subdivided into compartments. These are the simplified representation of our classes. In our UML class diagrams, we have our classes with the name of the class and also the name of the variables and the operations within that class. Now this shows a relationship between two classes. An ATM executes a transaction and that transaction is withdrawal. Current transaction is withdrawal. Our classes are related to each other within our system, within the same system, are related to each other in one way or another. We have studied different relationships between our classes. One of those was the composition relationship and the other was the inheritance relationship between our classes. Now we are given a general requirements document, and as analysts and developers of the system, we will have to work out what kinds of relation first. In the first, we'll have to work out the classes that we will have in our system, and then the associations between those classes. The solid line that connects the two classes represents an association, that is a relationship between classes. Now this line shows a relationship or an association between these two classes. The numbers near each end of the line are multiplicity values, which indicate how many objects of each class participate in the association. For example, if you see at these numbers, these show us how many objects of this class would participate in this association. So we have one object of the ATM and 0 at the minimum 0 and at the maximum one object of the withdrawal class will participate in this operation or this association. In simple terms, we mean that whenever we are trying to withdraw some amount, we'll need to have at least one object of the ATM. We will have to initialize the ATM's object to be able to work with our withdrawal amount. And if we are using the ATM system and if we are not withdrawing the amount, since we have other options in our ATM machine, we will be using 0 objects of the withdrawal amount. So we have that option over here. And if we are trying to withdraw any amount from the ATM machine, we will be using one object of the withdrawal class. So we have these options. We might either not be withdrawing an amount. In that case, we will be initializing 0 objects of the withdrawal class. Or we might be performing some withdrawal. In that case, we will be using one object of our withdrawal class. At any given moment, an ATM object participates in an association with either 0 or 1 withdrawal objects. As I talked about that, the numbers shows the multiplicity values are the number of objects of one class that will participate in the association with the other class. 0 if the current user is not currently performing a transaction or has requested a different type of transaction, and 1 if the user has requested a withdrawal. In the next figure, we will see an explanation of the multiplicity values that are used in a class diagram. For example, if we have used 0, then we mean none. 1 would mean 1. M is usually used for an integer value, so we can have more than one objects of a class participating in a relationship. So in that case, we will use M, that will be the number at that moment. If we know the number, then we will enter the number, the maximum number at that point. For example, here the maximum number is 1, so we have used a 1 instead of an M. 0 or 1, M, N, so it can be M, one value or another value. So these are integer values. It can be either M or N if they are separated by a comma, or if we have at least M in this case. For example, we have seen at least 0, so it will be at least 0 and not more than N. So this is the maximum number of an object, of the number of objects of a particular class participating in a transaction or in an association, and this is the minimum number. Any non-negative integer 0 or more, that is asterisk 0, or any number of objects, in this case 0 to asterisk, and this is at least 1 and more, so we use 1 to asterisk. If you have studied databases or you will study databases in the future, we will study the multiplicity types in detail, maybe when you study the ER diagrams or in your software engineering courses, but here, at least for the sake of some basic idea, this chart can help you with understanding the multiplicity types. An association can be named. We can name our associations as we have done previously. The word executes above the line connecting classes ATM and withdrawal, and figure 12.7 indicates the name of that association. As we saw, we were writing the word executes above the line that was connecting our ATM and withdrawal class, so we can name that association as executes. This part of diagram reads one object of class ATM executes 0 or 1 objects of class withdrawal. Association names are directional as indicated by the filled arrow head. If we go back to our diagram, you can see the direction of our association. So the direction of our association is from the ATM machine towards the withdrawal class. So association names are directional. The ATM executes the withdrawal transaction and the reverse is not true. Has a relationship. If you remember from our composition lectures, we can have a has a relationship or a composition relationship between our classes. Now the has a relationship or the composition relationship is shown by this darkened diamond shape. The screen has a relationship has a composition relationship with the ATM. Now the ATM will have a screen, the ATM will have a cash dispenser, the ATM will have a deposit slot, and the ATM will have a keypad, and all of these are shown by this class diagram. So this is where the class diagram can help us. It helps us identify the relationships in our software or between the classes in our proposed software. In the figure, the solid diamonds attached to the ATM classes association lines indicate that ATM has a composition relationship with the classes screen, keypad, cash dispenser, and a deposit slot. And we understand that in the composition relationship, we use an object of one class as a variable and the object inside another class. Composition implies a whole or part relationship, so it can be a complete dependence of one class on another class, or it can be a partial dependence of one class on another class. The class that has the composition symbol, the solid diamond on its end of the association line is the whole. In this case, the whole class is ATM, for example, and the classes on the other end of the association lines are the parts. So in simpler terms, the ATM class that can exist without the ATR system, but the other classes are part of the ATM. So we cannot have a screen without an ATM. We cannot have a keypad. We cannot have a cash dispenser or a deposit slot. So these classes are part of the ATM. So and these can be shown through the composition that the ATM will contain objects of these classes in simpler words. Now this is a more detailed class diagram for the proposed ATM system model, and of course it does not show the attributes or operations of our classes, but it shows the relationships that the classes can have between each other. So as we saw that all of these, the screen, the cash dispenser, the keypad and deposit slot has an composition relationship with the ATM. Then the withdrawal has the executes relationship with the ATM. ATM will also have a relationship with the bank database. It will authenticate the user against the bank database. And then the bank's database contains the account. So and in this case the bank database will have an object of the account class, since the bank's database contains the details of the account. And we can also see the multiplicity values indicated with each of these classes. So for example, an ATM will have at most one object of the cash dispenser class and vice versa. The ATM will have at most one object of the screen class. It will have at most one object of the deposit class. On the other hand, the ATM can have 0 or 1 withdrawal at the time, or and then it will be working at most one object of the bank database. And here in this case, the bank might not have any account details, or it can have many account details. So the relationship is 0 or many in this case. The withdrawal class also has a relationship with the bank's database, since the withdrawal can have access and modify the account balance, so it needs to have a relationship with the bank's database. As we can see, we are not providing any direct access to the account class. All of the access to the account class are through the bank's database, because the information needs to be updated within the bank's database to be available in the account class. Now in the next stage, we'll try to identify the class attributes. Classes have attributes and operations, as we have said that right from our beginning of this course. Look for descriptive words. Now what if we are not provided with any attributes? We will need to pick our attributes from the requirements document. And we can do this by looking for the descriptive words and phrases in the requirements document. For each word and phrase we find that plays a significant role in the ATM system, we create an attribute. So we pick important words from our requirements documents that we can say that are important to, for example, any of the classes of our ATM system. We create an attribute and assign it to one or more of the classes identified in a previous section. So for example, what do we do in the ATM is user is authenticated descriptive word. These were the words that we used for the ATM machine. There was in the balance inquiry was the account number. For the withdrawal, we needed the account number and the amount that we needed to withdraw. For the deposit, we needed the account number and the amount that we needed to withdraw. Now we can see there are some common details that all of these three classes are storing. This might be a hint that we might be able to use inheritance somewhere in this class, in these for these classes, but that is up to you if you want to use inheritance. And then for the account, let's say we needed the account number, the PIN code, and the balance of the user. And some of the classes we do not have any specific descriptive words or phrases. For the cash dispensers, it begins each day loaded with a certain amount of cash bills. So these are the hints from where we can identify our attributes, and then we can follow those attributes with the operations that we would perform on those attributes. Now this is the updated form of our class diagram. We have added the initial attributes that we have identified for our classes. So user authentication, that is a boolean value. We can indicate the default value for the boolean would be false. So initially any user is not authenticated unless he or she enters the correct details for their account. The account will have account number. As we can see, we can display the details like the account number is the name of our variable, and this is the for data type of our variable, the PIN code, the available balance, and the total balance. For the balance inquiry, we have the account number. For withdrawal, we have account number and amount. We do not have any variables for some of the classes. We might get variables for these classes with further analysis, But with our initial or very basic analysis, we have been able to identify the attributes for some of our classes. At early stages in the design process, classes often lack attributes and operations. Such classes should not be eliminated, however, because attributes and operations may become evident in the later phases of design and implementation. So, although some of these classes do not have any attributes at the moment, we should not be eliminating them, since with the further analysis and once we start our implementation of the system, we might be able to identify the attributes and operations of these classes. Once we have identified the attributes of our classes, we can move on to identifying the class's operations. An operation is a service that objects of a class provide to clients or users of the class. So what are the behavior or what are the things that a class is supposed to do? And that is defined through the operations or functions of the class. We can derive many of the class operations by examining the key verbs and verb phrases in the requirements document. So we can guess and brainstorm the operations of our classes by examining the verbs or verb phrases in our requirements document. The verb phrases in figure 12.6 help us determine the operations of each class. If we look at this chart, the ATM executes financial transactions. So this might be an operation of the ATM. Balance inquiries, nothing is provided so far in the requirements document, but we can guess from the name of the class that this is something that we'll be using for withdrawing the money from the account. But since we are strictly looking at our requirements document at the moment, this is what we get from our requirements document in our earlier slides. The bank database authenticates a user, retrieves an account balance, credits a deposit amount to an account, debits a withdrawal amount from an account retrieves an account balance, credits a deposit amount to an account, debits a withdrawal amount from an account. So these are the phrases that are described with each of these potential classes. A screen displays a message to the user. Keypad receives numeric input from the user. Cash dispenser dispenses cash, indicates whether it contains enough cash to satisfy a withdrawal or request. Deposit slot receives a deposit envelope. If you go back to the earlier slides of this lecture, all of these are the phrases or the verbs that were describing the process that the ATM machine is going to do, and these might be the operations of each of these classes. To put the operations within the class diagram, now we have the updated class diagram. As we can see that our class diagram is getting more details with each analysis process. So we have an execute function in our balance inquiry that would display the balance inquiry of the user. We have an execute function in withdrawal class that will execute the withdrawal function. We have a display message in the screen class. We have a get input that will get the input from the user, and with the return type that is mentioned in front of the function separated by a colon. We have an execute that will execute the deposit function, and then we have cash dispense cash for the cash dispenser, but it needs to check if it has enough cash available. And then we can see that our bank database needs to authenticate the user. It needs to get the available balance in the double form. It need to get the total balance, credit the amount and debit the amount. Then we have the deposit slot that if will check if it has received the envelope. Now we might need to add more operations or functions to the ones that we have identified initially. directly from our requirements document, but with the further analysis and implementation we might be able to add more operations. So if you try to add, let's say, parameters to our class bank database operations, we can see that if we have to authenticate a user, the bank should receive the account number of the user in an integer format, and it should receive the PIN of the user in integer format, and it will return in a boolean format if that is a valid user or not. So it needs to get the information before it can return the right information to the user or to the ATM machine. So if we need to get the available balance from a particular user, once the user must have been authenticated in the first case, then if we want to get the balance for that user, we need to get the account number for that user, and the balance will be returned in a double format. Same will be the case with the total balance. And if we need to credit some amount to the user's existing balance, then we need the account number of that user and the amount that we want to credit to the existing balance. And if we are debiting any amount from the user's current balance, then we need to get the account number of the user and the amount that we want to debit from the balance of that user. So we can also add in our UML class diagram the parameters that a certain function will be needing. And in the front, towards the front of the name of the method is the return type of that method. Similarly, the class account with the operations parameters, as we can see, if you want to validate a PIN, we need the PIN of the user. And if we again some of the classes, let's say the credit will need the amount, the debit method will need the amount. The screen, for example, the display message operation of the screen should get a message that it needs to display on the screen. The cash dispenser method, the method of the cash dispenser class should get the amount, let's say, that it needs to dispense to the user, and it needs to check, let's say, if the amount is available in the cash dispenser. Now this shows the relationships between the classes. For example, what are the classes that will need to call or send messages to the other classes? So the ATM will need to send a message to the screen class through the display message, a call to display message method. It will need to get input from the keyboard, so it will need to call the or send message to the keyboard class. It will need to send message to the bank database class to authenticate the user. It will need to send a message to the balance inquiry class to execute a transaction. Similarly, it will need to send message to the withdrawal class to execute a transaction, and it will need to send message to the deposit class to execute a transaction. Now sending the message simply means calling the a certain method of that is defined in another class or in any it may be in the same class, but we need, whenever we need to send the message we need to call that method. Similarly, the balance inquiry class will need to send a message to get the available balance from the bank database. It will need to send a message to get the total balance from the bank database. It will need to send a message to display a message on the screen to the screen class. The same will be the case with the withdrawal class. The withdrawal class would need to send a message to the screen class to display a message on the screen. It will need to send a message to the keypad class to get an input from the user. For example, the amount that the user wants to withdraw. It will need to send a message to the bank database class to get the available balance from the bank database. It will need to send a message to the cash dispenser to check if the sufficient cash is available before before the user can withdraw the cash. It will need to send a message to the bank database to debit a certain amount from the user's balance, and it will need to send a message to the cash dispenser to dispense cash to the user. Similarly, the deposit class will need to send a message to the screen class to display a message on the screen. It will need to send a message from the keypad to get an input from the keypad, for example, how much the amount that the user needs to deposit. And it will need to send a message to the deposit class to check if the envelope has been received. And it will need to send a message to the bank database class to credit some amount in the user's bank balance. The bank database class will need to send a message to the account class to validate PIN, send a message to check available class. Again, all of the messages are being sent to the account class, so we are not providing any direct access to the account class. All the access is being provided to all the other classes through the bank database. That is to secure the account details from the direct access and all of the modifications will need to be done within the bank database first to be uh, displayed on the user's account information.